All right. So today, and I hate to say it, but it's not a very long lecture. It's not very difficult. But when you walk out of here, you're actually going to say to yourself, I feel smarter. Some of you will. Now, some of you are like, nope. It's all the same. All right. Oh, I gave you the wrong ones. Here. Let's actually give you the version that has the blanks in it. All right. Some of you will feel that way. All right. The first thing that I want to talk about, and it's really important because it's a little foreshadowing into what we're going to do after Thanksgiving when we write balanced equations. What this topic is writing formulas. So we're writing out compounds and compound names and writing out the formulas for that. What I have here is just these elements when they're by themselves. They're alone. Okay, they're not in a compound. So you might want to write not in a compound. Okay, or better, alone. So when I look at hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and notice that those are all in pairs, a group. An easier way to remember this is if it ends in ine, so it ends in ine or gen, okay, like fluorine, chlorine, bromine, iodine, okay, you could say ine or ene there, or gen, nitrogen, oxygen, hydrogen. If it ends in ine or gen, when it's all by itself, or all alone, it's diatomic. That's what this first blank is dealing with. So diatomic means that like the nitrogen, the hydrogen, the oxygen that's in the air, they're going around with a little buddy. Okay? And it happens to be their twin, so to speak. Isn't that nice? So this, what I just did there, has nothing to do with what we're doing today. You like that? I always like to give you a little bit of something for the future. I always love doing that to everybody. All right, so what we are doing today is we're going to write compounds or formulas, and we're going to name them and also write out the formula. So here are some of the rules. So rule number 1, represent each kind of the element in a compound with the correct symbol. Okay, so if you're trying to represent carbon dioxide, don't put nitrogen in there. Okay, it's kind of one of those common sense things. Number 2, use subscripts to indicate the number of atoms of each kind of element in the compound. If there's only one, don't use a subscript. So like for example, if we write out H2O, we don't write H2O1. You don't do that. Okay? If you have at least one element represented, no subscript is needed. Okay? Kind of common sense there. Number 3, which you don't have to worry about in here, write the more metallic element first, and you might be saying to yourself, well, there are no metals, and you're right. There are no metals in what we're doing today. But the trend is, as we go in that direction, the elements become more metallic in property. Now, we'll talk about, like this first one here, sulfur dioxide, or sorry, SO2, and they actually appear right there on the periodic table with oxygen there and then sulfur right below it. We would write the sulfur before the oxygen because sulfur has more metallic properties. Is it a metal? Absolutely not, but it has more metallic properties. What does that mean? We don't care. Okay, that's beyond the scope of this class. And we don't talk about it in AP either. Okay. But what's nice is I will always, for these types of things, tell you who is more metallic. Now tomorrow we're going to have a metal with a non-metal. So there I will say like, okay, I've got some chlorine, I've got some copper. You'll have to say which one's a metal. Write it first. Okay. So this is what this is trying to represent here is that I have SO2, so I've got representing sulfur, representing oxygen, and that the not the diatomic, but the 2 there represents that I have 2 oxygens. Pretty straightforward. We don't have to worry about how we found these elements. We don't care. Okay, but people went into the lab, they did analytical chemistry. We will not be doing that. All we're going to do is learn how to name them and write them. Awesome. So here is what I'm calling this. It's called binary molecular. What does binary mean? 2. Good. And if you talk about binary code, you're talking about zeros and ones. Well, here, when we talk about these, we're talking about 2 elements. So whenever you hear binary, it means 2. Whenever you hear the word molecular, that's non-metal with non-metal. Tomorrow we're going to talk about ionic. That's metal with non-metal. So whenever you hear me say, ooh, that's a molecular compound, what I'm actually referring to is that I have a compound that's made up of only non-metals, which is a really small portion of the periodic table. So when we look at the periodic table, where are you there? Okay. We're talking about a very, very small area here on the periodic table. And what's neat is, if I look at it from here, put a dot in the middle of carbon, put a dot in the middle of fluorine, put a dot in the middle of the iodine, if I could draw a straight line, I call this my non-metal triangle. If it's not in the triangle, we're not working with it. Okay. Notice that the noble gases here, they don't form compounds. There's a couple that do, but those are the fun ones. They're so big they don't realize that things are attaching itself to it. Okay, but that's all right. But up here, these guys don't form anything. But this is the non-metal triangle. So this is what we're working with today. Tomorrow, we work with everybody. That's in our 52 element realm there. Okay. All right. Oh, and I put a note on here. There's no way that you're ever going to know what all these things make or what they do. All we're doing is just naming them. So when I give you a compound, don't go, what does that do? I'm just going to say it. It'll make you beautiful. Okay? Beautiful. Yeah, you take it. It'll either kill you or make you beautiful. How's that? Worth it? All right. Now, since we are working with non-metals today, where tomorrow we're going to be working with ions. Ions have charges. These do not have charges. So we have to have some way to tell everybody how many of each we have. That's what this is, the Greek prefixes. And the Greek prefixes tell us how many of each of the elements we have. So 1 is mono, 2 is di, 3 is tri, like tripod. 4, if you ever played Tetris, Tetra. Okay, there's 4 blocks, different arrangements. And then penta, hexa, hepta, octa. Now for this class, we don't go beyond octa. In AP, we go 2 more. We go nano and deca. Whew, it's exciting. Okay, but the reality is, this is all you need to know, for at least for my class. And I don't know what Mrs. Sedgwick does, but she might go nano, deca. Okay, but you're not losing anything by not knowing those other 2. But you do need to know these Greek prefixes. And the only time that we use the Greek prefixes is when we have a non-metal with a non-metal. That's the only time. You will never, ever, ever use these after or when we have metal with non-metal. So, mono, di, tri, tetra, penta, hexa, hepta, octa. Okay. So there's something you get to memorize. Here are the rules for naming molecular compounds. Number 1, name the elements in the same order that they appear. Okay. Number 2, drop the last syllable, last 2 syllables, and add IDE. Now, when I was in kindergarten, 1st grade, we did syllables like this. Oxygen. We clap. Now, my wife says that she does it like this. Oxygen. I don't know. However you do it, clap. How'd you guys learn? Did you clap? Or? Good. You're like me. Very good. You got a good education. My wife goes, no, they go like this. I'm like, clap. All right, so, like for example, we have oxygen. In that case, we're going to drop the last 2 syllables and then add IDE. So you get rid of the Y-gen. Now you have not oxygen, but you have oxide. So oxide. Okay. And then number 3, add the prefixes to each of the elements to indicate how many you have. However, traditionally, what do we call it? Well, let's start with this. What do you call that? Something you breathe out. Carbon dioxide. Notice we didn't call that mono carbon dioxide. Because historically, if it's the first element and there's only one, you don't put a mono on there. We only use mono for the second one. So hopefully your furnaces are working, because if they didn't, they'd be producing that. Carbon monoxide or monoxide. Okay? So the only time that we use mono is for the second element. Okay, makes sense? It's going to be rather easy. So here is the steps, and it's kind of very, very elementary in my case. So we have 1 carbon, 2 oxygens, and you would never do this when writing it out. This is what your mind's thinking. So I go, okay, I've got carbon and oxygen. Good. Next step is I'm going to drop the last syllable, last 2 syllables in the second thing, and put IDE. So now I've got carbon oxide. Then the third thing is I'm going to put my prefixes on. So now I've got monocarbon dioxide. And then the last step is, well, we never put mono on the last one, so drop that, and now you got mono, or carbon dioxide. Sound like fun? Let's do some examples. Yeah. The only time that we're going to add anything today is "ide." If it ends in "ein" or "gen" or anything else, drop that last syllable and add IDE. Let's actually go, that's a good point. Let's look at and make sure that we know these. Okay? So again, that non-metal triangle. We won't use boron. Again, it's the moron. We're not going to call that boride. Okay? But we'll start with carbon. So carbon, drop the bun and add carbide. Okay? What is this called? Nitride. Good. What is this? Oxide. Just did it. This is what you brush your teeth with. Good. That's the active ingredient. We don't do anything with silicon. What is this? Phosphide. Good. Sulfide. Chloride. Here's the tricky one.
You don't do it.
Yeah, you do.
I was trying to be clever.
I don't care how you say it.
Selenide.
There you go. That's good. That's close enough. Bromide. Iodide. And that's it. Okay. So those are, if they're the second element, just drop the last syllable and add IDE. Okay. No, be nice. All right. Let's do some. Let's zoom them in here. All right. So what is that first into 04? Again, you're going to walk out here going, I know something. So we got a di because we have a 2, right? Dinitrogen. Good. So the first element, don't mess with it. Okay. You might be adding a prefix, but you don't mess with it. So we don't drop anything in the first one. We only drop it in the second element. And if you want to hyphenate, I love hyphenating because in some cases you might have 2 vowels and they might be the same vowel, and you're like, oh, do I drop it or do I? Well, if you hyphenate it, you can keep everybody. Okay. And then what's the 04 called? Tetra. No quads. We don't have quads in chemistry. Tetroxide. Whoa, what the heck was that? I don't even know where that came from. Okay, so dinitrogen, tetroxide, N2O4. Okay. What is SiC? Silicon, good. Ooh. Again, no mono on the first one. So silicon, mono, carbide. There you go. So silicon, mono, carbide. Again, mono's only going to be on the second one for whatever reason. So silicon. I hyphenate all of those. Okay. No. So if you want to put on monocarbide, that's fine. Yeah. Say it again. No, put the B in there. Yeah. So, in other words, you may not be pronouncing it right. Carbon. Carbon. No, it's carbide. I make it. You gotta wake up.
I'm tired of trying to explain.
There you go. All right, what is B? Carbon disulfide. Very good. Carbon disulfide. Carbon. Again, don't put the mono on there. What's that? It's you. Yeah, Julianne. No, never put the IDE on the first one. It only goes for the second one. And what's nice is that'll be the rule tomorrow as well. Okay. Oh, so Cade's saying that SF6 is sulfur hexafluoride? Yeah, good. Silicon dioxide? Is everybody good with Cooper? What is it? What is D? D. What is E? Diboron trioxide. What is F? Oh, you're back here. Okay. Dinitrogen. Now, here's a nice reason why I like to hyphenate it, so you're not going the A and the O. Whoa. Hyphenate it, and then we can see the pentoxide. Okay. All right, so G is tetrasulfur, hexa oxide. Very good. Okay. And then what is, let's change this from a 9 to an 8. Sorry about that. Because we're not doing nano in here. Nano and deca. So let's go P5Cl8. Pentaphosphorus. Octa, remember octopus? Chloride. Okay. Now, that's the hard part. Seriously, that's the hard part. Yeah, writing the names. Here's where it gets fun. I'll let you tell me if this was easy. What was that? We changed that to an 8, so it's octa chloride. Yeah. All right, so how do you write chlorine dioxide? ClO2. Okay. Now let's do this right now because I know some of you will make this mistake, and I don't ever want you to make this mistake. We will never ever have a carbon and an iodine. Okay. You'll never have carbon iodine. If it looks like carbon iodine, you're looking at a chlorine. Okay. So I'll never do carbon and iodine in here or in AP. So it's always going to be a chlorine. So if you see something that looks like, ooh, I wonder if that's carbon. He gave us 3 elements. Dang, no, I gave you 2. All right. So how do I write B, Abby? How do I write B? Okay. Is that hard? Didn't think so. What is C? P3O4? Pretty easy, right? Sometimes I'm actually telling the truth. Not often, but yeah, sometimes. Looking at D, E, F, and G. All right, so D, tetrasulfur dinitrite, kind of clipped it off there. So S4N2, good. What is iodine heptafluoride? IF7 hepta. You're thinking of tetra is 4. What is tetraarsenic octaoxide? Oh, wait. Very nice. Look at it. You guys sound smarter already. Pentasilicon heptaoxide. Si5. So we have two more? Yeah, go ahead, Noah. I got you. All right. So H, tricarbon hexa C3Cl6, and then phosphorus monochloride, TCl. Don't you feel smarter that you're now writing chemical formulas? Sure. Poor Cade. All right, the homework. What's that? What's on the board? So the homework is this one, writing molecular compounds, binary compounds. And I did make a video link. Sadly, none of you will probably watch it. There's been 24 hits on it so far. And it's a year old, so it's pretty pathetic. What's that? What do you mean? They're always linked. Oh. Now, keep in mind that half of these you're doing the same thing that we did. So half of these you're going from the formula to the name. The other half is the name to the formula. Last period it took an average of 11.3 minutes to finish this. So done. But if you do need to see the video, there it is. The video link should be active.